So thank you everyone for joining. It's really nice to see everyone, especially in person after like 2 years. I think
Yeah.
it was 2 years basically. One of my last conferences was Berlin as well. So thank you for joining. Today we'll be talking about how we built our chat SDK using Jetpack Compose here at Stream. My name is Filip Babić. I'm the lead Android developer for Jetpack Compose at Stream, which generally means that I do a lot of compose and kind of running the SDK, trying to maintain it, improve it for users, and so on and so forth. I'm also a GD for Kotlin and Android. So I do a lot of public speaking, content creation whenever I can. If you want to reach out to me, you can do so via Twitter or LinkedIn. And here's Márton, who's going to give us a bit of info about why we chose Compose for Stream.
Yeah, so my name is Márton. I'm an Android developer advocate for Stream. I stole Filip's bio because we do very similar things. And the best place to find me is generally on Twitter or on my website. So let me give you an overview of what we're going to talk about today first. So we're going to start with why Jetpack Compose, why it's exciting for everyone, and why it's exciting for Stream specifically. Then we'll talk a bit about our thoughts on Compose and using it in production. And then we'll dive into our actual SDK. We'll take a look at how we've designed our various components that we provide for you. We're going to take a look at some common pitfalls and concerns that you might have around Compose. We're going to give you some tips around writing readable Compose code. And finally, we're going to take a look at how we achieve customization things in our chat SDK. So why Jetpack Compose? Let's start there. We, just like the community as a whole, probably, as well as Google, strongly believe that Compose is going to change Android development forever. It's going to simplify a lot of our lives. Of course, one of the main promises is that it's going to give us faster and more efficient UI development than what we had with the existing Vue and XML-based UI toolkit. It, of course, has some initial learning curve. Like any new API, you're going to have to put some time into learning it. But it's also fairly intuitive overall, and you can discover a lot of Compose things just coding away in the IDE through autocompletion and similar features. Compose is declarative, which is something that many modern UI toolkits have been gravitating towards. It turns out that it's a really good idea to model UI as a function of whatever state you have in your application. And in Compose, all of our components are simply functions, which is really powerful because in Kotlin, we can easily pass functions around, which means that we can offer all kinds of deep customization using these. And of course, it's all Kotlin. Hopefully, everyone here loves writing Kotlin code. And Compose is all Kotlin, which means that we can write Compose without having to bridge the gap between XML and Kotlin like we used to have to, like looking up views, doing view bindings, and all that. And all of our editing and writing of Compose code is just the same as writing any other Kotlin code. So we do it in a familiar environment. We have all the tooling. We have all the IDE features for it. So it's really nice that we can do all of this in Kotlin. Why is Jetpack Compose interesting for Stream specifically? Well, we really want to meet users where they are. So our service is a chat API, which is a backend service, which is paid. But we also have free trials. And if you're a small company or an independent developer, you can actually use our service for free. And to that paid backend service, we provide many different clients. For example, we provide client-side SDKs for Android and iOS, both native SDKs, but we also provide React Native and Flutter SDKs that all match their respective development experiences. We also do the same thing on the server side. So we have clients for JavaScript, Java, Ruby, Go, whatever server-side language you're using, really. And we want to do the same with Compose. So you could technically use our existing Android SDK that has views in it in your Compose applications, but you would have to use Compose's interop features, and it's a bit difficult to do so. So instead, we're creating a Jetpack Compose SDK from the ground up that will have idiomatic APIs for Compose users. And it also turns out that Compose is a really, really good match for the needs of our SDK. What we provide is UI components that people put into their applications, and we want those to feel at home within your app, within your product. So with Compose, we can offer customization, such as theming and slot APIs, that were very difficult to do with the regular Vue and XML-based UI toolkit, if not completely impossible in some cases. But then in Compose, they become very easy, sometimes trivial. So using Compose in production then, is it actually ready? What were our experiences like? This is going to be a very brief section. What we're going to say about Compose in production is that it has been stable for us for a long time now. We built most of the SDK while Compose was still in a beta version, and we never had any stability or performance issues with it at all. And while the core APIs are stable, you might still run into some experimental things. Every once in a while, there are problems that haven't quite been solved in a definite way in Compose yet. And you can avoid these for the most part in your day-to-day work, but you should know that there are some experimental things, and don't be afraid when you encounter those. Some quick examples of what might still be something experimental that you have to use. There are the accompanist libraries from Google, which are first-party libraries by Google, but they are not shipping them as Jetpack libraries yet because they're not quite sure that they're going to be the solution for those given problems in Compose. You can probably use those, and Google is, of course, going to give you a migration path, if possible, if they come up with something better. But it's technically still experimental, so it's up to you to commit to using them and might having to potentially change it and maintain it in the future. There are also some lazy APIs that are still not stable. So we have lazy columns, lazy rows, which are really cool, and those are stable API. But things like sticky headers in these kinds of lists or lazy grids are still marked experimental. And there are also some modifiers and some material components, mostly related to complex click handling, that are still experimental. So again, it might change in the future. Be prepared for that. I wrote a blog post about using experimental APIs that you might want to check out. This is useful to understand how to create these APIs if you're building APIs for others, but also a good resource if you are just a user of Compose, for example, where you'll regularly encounter experimental APIs. So with all that, we can say that Compose is production ready and it's here to stay. And we, for example, are very committed to building Compose. So our Compose SDK was built in about 2 months, pretty much by Filip alone. And it's hard to compare this directly to our XML Vue-based implementation, but we spent multiple months on that as well, and we had multiple developers on that project. So it's hard to compare, but as a rough estimate, we can say that we can move about twice as fast developing Compose components than what we could do with XML. And with that, I'm going to hand it over to Filip, literally, to talk a bit more about how our SDK actually looks like.
Yeah, so thank you, Márton. Now that we kind of reassured ourselves about Compose, that it's actually production ready, even though there might be some experimental APIs, we can take a look at our design system and how we built all of our components, what types of components we provide, and why we actually do those things. So we have 3 different types of components. Because we have a very fine balance in our SDK, we are providing an SDK for other people to use, for other developers. So we have a fine balance between having very default implementations that work out of the box, where you have or don't have to do pretty much anything or just write a few lines of code, and everything is set up for you. And we also need to do a very deep customization or set of customization options for our users, because obviously we can provide a default design, a default set of behavior, and so on, but our users might want to, and most generally, want to customize the UI, but not just UI, and also behavior and things like that. So because of that, we decided on 3 types of components. The most basic or the most simple components to use are called screen components. And as the name states, they are used to build screens, like entire screens of features. So they are out-of-the-box solutions that give you an entire screen. So for example, a messages screen where you can chat with other people, or a channel screen that you can browse your channels or conversations. They have limited customizations because these are really useful for MVP solutions. These are great to test our API to see if it works for you, if you want to go with this type of design, this type of feature sets, and so on. So in our tutorial that we'll talk about, you can literally integrate all of our screen components in just like 5 minutes or 10 minutes, something like that, and have a chat application working on your phone, more or less. But you generally don't want to do just that. You want something a bit more custom. You want something a bit more closer to your design system and set of features, which is why we have bound components. And they are bound to our view models because we don't really want you, again, to have to worry about data operations, where the data comes from, triggering different events such as sending a message, and so on and so forth. So we bind our components to view models so that everything is set up for you. So they are, again, out-of-the-box solutions, but only for a portion of the screen, which means they are more customizable as you can combine them with the rest of your UI, or you can combine them with some of our other components. And we'll take a look at how this actually looks like. And finally, we have the last layer, or the lowest layer, so to say, which are stateless components. They are generally alternatives for bound components or some very specific small components, such as the avatar or a timestamp and so on. They are stateless because they are not bound to any types of view models or any kind of view model logic that we have. They are driven completely by state. So if you give them an X amount of state or a type of form of state, they're going to show different types of UI, and they're going to work in basically how the bound components work. So everything is going to work accordingly. It's just driven by your state, which offers you full customization because you can control the lifecycle of them, you can control where the state comes from, and also you can control the UI and the behavior, as we mentioned before. So if we take a look at one of the screen components, as I mentioned, the messages screen is really good because you can integrate it within just like a few lines of code. And it shows you an entire screen, a rich set of features on the messages screen. So here you can see all the messages in a specific conversation. You can see things like threads, like URL previews. You can see attachments and images. You can browse these attachments, and so on and so forth. So it's a complete chat experience integrated with only 5 lines of code or something like that. When we take a look at the signature, we notice that the only important or required parameter here is the channel ID, so that we know which channel you're trying to converse in, as we can't really like guess that ourselves. The rest of the parameters customize smaller things, such as do we want to show the header, how many messages we want to load on each pagination load, and things like that. But you get the entire screen with basically 1 line of code if you just pass in the channel ID. Next, we have the bound components. As I mentioned, these are very specific, a portion of the screen, but again, out-of-the-box solutions. So here we have the message list, which represents the list of messages on a messages screen. Again, it's very easy to integrate. You can just put it with the rest of your UI or in your set content function or something like that. And you can combine them with both your UI, which is completely custom, and our components, which, again, you can customize. When you take a look at the signature, again, we notice that the important parameter here is the view model. As I mentioned, we have to bind this component to a view model. So in that sense, it's going to load all the data from the view model. It's going to set everything up, and you don't have to worry about anything. But if we take another look at the signature, we see that all of the actions or handlers that we provide are pointing to the view model by default. So when you click on a thread, long tap on an item, and so on and so forth, it changes the state in the view model, and it triggers all the operations that are required. It changes the state for you so that you can show different types of UI if you want to customize the app even more. And finally, we have the slot APIs, as Márton mentioned. Here we have the item content composable function, which represents each item in the list. So it can be anything from a simple text message to a date separator, something that we also have, but not on the screen, things like attachments, and so on and so forth. But this is a default implementation. If you want to completely customize it, you can do so. And we can actually see a few examples here. So on the first screen, we see a very default implementation, which you just have, where you just have messages, some timestamps, avatars, and so on. You also have attachments in general. On the second screen, we have pretty much the same, but without the timestamp, so it's a bit more lightweight and more colorful if you're building some kind of an application that looks like that, I guess. And on the last two screens, we have very limited or very simple types of UI if you really need if that's all you need for your application. So on the last screen, actually, you can see that this is essentially like a Slack clone application or a Slack clone message list.
Messaging.
Yeah. Basically, it's very simple, but it's all done through the single item content parameter that you can customize to your will. So you get the data that you need, and you just basically do whatever you want with it. As I mentioned, all of the bound components use stateless components internally so that it's very decoupled and we have uniform behavior across these components. And we can take a look at the messages component, which is the message representation of the message list. So the message list has different types of states, such as the loading state, empty state, and so on. And here we see that the stateless component, the stateless version of the messages, has two important pieces of it. So first is the messages state, which actually gives us information what type of state we want to show, and the item content, as we mentioned, to customize how the items look. When you take a look at the messages state, it's nothing really complex. It's nothing really like super custom or super hard to understand. It's just a state wrapper that holds a bunch of different smaller parameters. So in this case, we can group these parameters in a few groups. So the first group is the first three flags, which generally renders if we're showing our loading state or a pagination state. And here we can see that if the isLoading flag is true, then we show a loading spinner for the entire screen because we are doing the first load. On the other hand, if we have the isLoading more or end of messages flags in like a good combination, so we are trying to load more messages and we haven't reached the end, we show a loading spinner, which is really good because all of this is combined into one class and we don't really have to think about fetching all of this data from the view model all the time. On the other hand, we have the message items, which by default are empty. So if there are no messages, we just say, hey, there's no messages, we can start chatting. This screen is also customizable, so if the user wants to customize the empty state, they can also do that. But if we have messages, we basically see the screen that we've seen on the previous few slides, where you can see user messages. And finally, we have like a miscellaneous group, which handles like a few different smaller states. So if we have a selected message, we can show an overlay. If we have we have some combination of states, such as the current user and the parent message ID, then it means that we are currently in a thread. And finally, if we have a new message state, basically a state that gives us if we have any new messages after we scroll through the list, and the unread count, we show an unread message indicator. So here's how that looks. Basically, if we have a selected message, we have an overlay with a bunch of options for the message, such as adding a reaction, replying, and so on. And if we have new messages state and some unread count, then we show a scroll to bottom button with the unread count. So the user can scroll to the bottom, they can see how many messages they missed. And the thread state we didn't really show here, but it's basically messages, but within a thread instead of a regular message list. So now that we've seen how our components work and how we design them, we can take a look at the common pitfalls that we had while working with Compose. Some of the things that you might run into yourself and that you should probably avoid or try to avoid. And obviously, the very first thing is thinking too imperatively. So if you're coming from XML, it's very easy to run into that imperative way of doing things. In Compose, because everything is a function and everything is declarative, you can't fetch the view by ID, you can't fetch any types of components, set any listeners, and so on and so forth. So you have to declare everything ahead of time. So a way to avoid this is basically go through the examples or like guidelines courses for Compose. Try to just put your fingers on the keyboard and like typing some Compose code so that you have this declarative mindset slowly coming to you and just like trying to avoid what XML usually does. Another thing is hard-coding customization. So generally what happens is that you want to provide modifiers for your users so they can customize components. But if you hard-code modifier customization in your components, then you essentially override what the user sets. So it's really important to be careful about exposing modifiers if you want users to customize these components. And then if you're exposing them, not to use too many custom or like very hard-coded modifiers for your apps. So make sure that you don't hard-code too many things. Next thing is really simple, I guess, but it's very easy to miss, which is migrating too quickly. So similar when Kotlin became first class in Android, everyone wanted to move their applications to Kotlin, obviously, because it's so awesome. But you shouldn't really like move immediately. You shouldn't try to translate the entire application in Compose from XML. You should slowly migrate, slowly start composing up from the bottom. So basically, start building smaller components, smaller parts of the screen, newer features, something like that, and slowly composing all of those components together into a more complex UI. And finally, we have a lack of examples out there currently, a bit of a lack. Even though there's a lot of resources, there's Google guidelines, obviously, there are Google courses, we have presentations like this. It's very hard to pinpoint every single issue or every single design decision that you have to make when building your applications. So because of that, make sure that you talk to the community, that you visit Kotlin Slack or some of the Compose community events and things like that, that you talk to people, that you also try to experiment yourself a bit, because there is a lack of some best practices out there, so you might as well set some of those best practices yourself, or just like figure out what works for you. Some of the common concerns that we've had while using Compose and trying to replicate our XML SDK are the following. So we were very worried about how we were going to do dynamic size components. So for example, we have an avatar component that shows up to 4 user images. In XML, we had to load bitmaps and create a matrix and do some calculations, stuff like that. In Compose, we just used a couple of rows and a couple of columns and used weight modifiers, so that things essentially organize themselves based on the weight and the number of components. And it turned out to be stupidly simple, actually. It kind of works, but it looks silly at the very first time that you look at it. The next thing is message list optimization. So just in general, we're trying to build a chat SDK, or we built one, and you're trying to build chat applications, so you need real-time updates. We have a huge diffutil essentially class for XML that we have to manually write to make sure that we have optimistic updates. In Compose, we didn't generally do any of these things. We just used the basic components, and we added keys to our messages, and that's pretty much it. So we didn't really have to do any kinds of optimizations on our end to make sure that we have optimistic updates and that everything works really fast. And finally, we had some of the things such as customization. How do we apply, let's say, custom attachment factories for custom attachments, obviously, for colors, for typography, and so on and so forth. In Compose, it's again very simple, because we can just declare a parent component that is a wrapper for everything. And through that component, we can provide all of these options, all of these properties, and propagate them all the way to all of the rest of the components. And it just kind of works. You change the theme, and everything updates accordingly in real time. And one of the final things that I want to mention, because before we go back to customization, to Márton, we wanted to avoid falling into the trap of component hell that's very common in declarative frameworks. So if you don't know what this is, essentially in frameworks like React Native and Flutter and so on and so forth, we have this way of composing components that everything has a parent, and then you have some children, and a number of them, and so on and so forth. So if you want to propagate or wrap things in attributes, similar to what you, I guess, do in CSS and HTML, they have different types of nesting involved in your components. They can be really hard to maintain, really hard to customize and change. So what we kind of suggest that you try to do is move to a more flat structure, where you try to avoid as much nesting as you can. And while you're doing that, try to decouple your components in a logical way so that they're kind of self-centered and they are basically like working in an individual way. So you don't really have to worry about if they're going to work in another component or another parent or something like that. So here we have an example of the messages screen. Essentially, the parent for the messages screen is a box which fills in the entire screen, or whatever the user gives us. We have a scaffold that shows the top bar, the bottom bar, and we have some content. The box is used to allow us to overlay stuff. So if we want to show different types of overlays, we can do that. And we do that in the following way. So after the scaffold, we just have a bunch of smaller checks, such as if we need to show a selected message overlay, the attachment speaker, or something else. And as you can see here, and I can't really use the laser to point it correctly, but everything is on the same line. Everything is on the same level in terms of the nesting. So there's only effectively one layer of nesting here, which is the box. And that is just used to overlay things. So it's very easy to reason about. It's very easy to go through and to change something or add more overlays if you need something like that. And this code essentially provides this UI. So we have the attachment speaker, we have the selected message overlay, and we have the alert dialog, and they all live in the same hierarchy, essentially, and everything works as it should, and everything looks as it should. But if you were to go into a more nested kind of way, you might have a bottom drawer component that you might want to show across your UI. Within the drawer, you might have to show the attachment speaker. But you might animate that picker in a different way. So you can wrap it in an animated visibility component. And here we have 2 or 3 layers of nesting just to get to the attachment speaker. After that, we use the content that's always shown in the bottom drawer, which can be a scaffold, or we just put a scaffold here, but it can be like a column or something like that. We have more and more nesting. So it's really hard to reason about this. It's really hard to understand what's going on. So as I mentioned, like going to a more flat structure, it's much more easier to understand and easier to change if you want to customize anything.
It's also hard to like move data around there. So you have to like move everything up the tree and then down again.
Yeah, so in this case, if you have like this level of nesting and you decouple your components, you might have to pass a bunch of different types of state to a bunch of different components. Essentially, if you have like a very flat structure, you can declare all of your state at the very top and then only pass in the state to the components that actually need them. So you don't have to do a lot of nesting or a lot of basically prop drilling, I guess. And with that, Márton is going to give you a bit more insight into how we customize our components.
All right. So as Filip said, our general mindset for customization is that we want things to work pretty nicely out of the box. We want to give you default components, default looks, default theming for everything. But we also want you to be able to customize everything so that it fits your exact needs. Here are some things that we are doing that you might probably also want to do if you are providing APIs to others. So first of all, really important and also kind of simple thing, always provide a modifier parameter on your components that you're exposing as public API at least. This is something that's part of Google's official Jetpack Compose API guidelines. And these guidelines are a super valuable document. It's a very long, like super detailed document that gives you a lot of good tips about how to design APIs, including a detailed description on how to give users modifier parameters. Then think about exposing content parameters and slot APIs wherever it's appropriate. There are going to be some components where slot API is a requirement because you have to have some input from the user to render your component. But also, if you're just building a large component, think about the possible customization needs that your user might have and see if maybe it's worth splitting up some of those smaller bits inside a large component into slot APIs. You can still provide a default implementation and have all default looks everywhere like we are doing. But this way, the user also has the ability to override the UI. Then think about theming. It's nice to use modifiers to individually customize each component that you provide from your library. But it's also important to be able to customize the components as a whole. So for example, if you want to change colors in components, then you don't want to have to do all of that through modifiers or individual parameters whenever you use these. It's much easier to do it through some global theming approach. And you can either hook into material theme, which Compose includes by default, or you can build your own theming. And finally, provide the kind of customization things that Compose expects you to have by default. So providing state parameters that drive the components externally, and then providing action handlers for all of the different kinds of events that are happening in your component is really important because, well, if you don't provide those things, your users are going to have a difficult time hooking into certain events. Even if these are just empty by default, it's important that you create these parameters. Here's an example of us providing these different kinds of customizations in our message composer. As you can see, we can break up the different parameters into 3 different groups: state, action handlers, and then finally UI customization and slot APIs. So first up, for state, we're expecting a view model here. This is the bound version of our message composer. This will communicate with the API under the hood, grab data from it, and populate the message composer with whatever data it needs. We, of course, also ship the state test component that Filip mentioned, which the bound component actually depends on. And if you don't want to depend on our view models, you can just use this stateless variant, which you can drive externally by just providing simple data classes, values like a string, and the component will simply display those. Then we have action handler customization. So in the case of bound components, we're defaulting to handling all of the actions that we possibly can by default by propagating it to the view model. So for example, when the value changes inside the input field, we're going to update the state in our view model. Or when the send button is pressed, then we're going to use the view model to call into our API and actually send a message. The exciting part, of course, is that you can customize and override these. And here's a quick example where we're actually still calling into the same method on the viewModel. We're still using viewModel.sendMessage, which just performs that action using the API, and you don't have to know the details of it. But these handlers can be overridden to provide hooks. And for example, you get the opportunity to customize the message before it's sent. So you could modify the text in it. You could add arbitrary extra data that our API supports, like some metadata related to your domain, or well, whatever you want to do, really. Finally, we provide a modifier parameter, which we omitted because, of course, we always provide that. And we also provide a bunch of different slots. So for example, for this simple-looking message input view, we provide these 3 slots so far. So we have a slot here for the integrations, which by default is a button to open the attachment picker. But there are clients who have many different needs of what kind of actions they want to provide to users around the input. For example, you might want to start recording a voice message, or send your location, or open a sticker sheet, or whatever else in the chat. So you can just input any composable content here, and that will be displayed to the left of the input field. We also have customization for this hint, this label inside the input field. We could have just made this a string so that you can provide a new value of what to say in here. But what if you are using your own custom text components in your application and you want to render this string with that? Or what if you want not just a piece of text, but also some iconography next to it? In those cases, again, you can just provide a composable here, which lets you input arbitrary UI. And finally, we also provide this large slot inside the composer, where you can just override the entire message input field. And of course, you have to integrate this with the viewModel if you want to hook into the state and the implementation of actions in there. Finally, let us show you our theming implementation. So our components don't match the exact theming system that Compose provides through material themes. So we have our own instead, which is well simply called Chat Theme. And it works very similarly like how all of the default Compose theming approaches work. Basically, Chat Theme is a wrapper that you can wrap any composable content with. And it provides all of the parameters that it receives as composition local values to the content. So this means colors, typography, shapes, and so on can all be customized in this top-level chat theme, which has to be present somewhere in the top of your composable tree that then includes our components. And our components will take these values from chat theme through these composition locals and use those colors and so on. So for example, for colors, you can see that we defined a stream colors class, which we basically provide 2 sets of colors by default. We provide dark and light mode color schemes. And this is then provided to the content that's wrapped by chat theme. And this is just a simple data class. We use these 2 sets of colors from our design by default. But if you want to brand our chat to match your product, you can just copy this data class. You can adjust some of the colors. Perhaps you can override the primary accent color with your brand color and so on. And that will affect all of the components that you wrap inside chat theme. To wrap up, we want to give you some resources that you can discover. So first of all, our SDK and all of our client SDKs are open source on GitHub. So you can check out the repo. You can contribute. You can open discussions, issues. We're really open to that. We're also running the entire Compose project in GitHub issues and GitHub projects. So you can see like in real time what Filip is working on. Oh, and of course, please star our repository if you like it. To get started with Compose and try this SDK, as we said, it's about 10 minutes to build a basic messaging feature with it. The best place to do that is the Compose tutorial that we have. We also have full documentation on all of these components, so you can learn how to integrate them, how to customize them. And if you want to follow our release notes and our latest developments, you can follow our company account at gueststream_io on Twitter. We also want to give you some Compose-related resources. So first of all, again, if you're building APIs in Compose for others, please read that long guide from Google, which gives you guidance on how to design Compose APIs. Then if you're looking for more beginner content around Compose, you can take a look at Google's Compose pathway. That's a really nice way to get started with it. And finally, we have a link here to a GDG YouTube channel, which contains some talks by Filip on both basic Compose and then some more advanced features.
Yeah, the talks might be a bit outdated in terms of the Compose version used for it, but they are talking about fundamentals and how to use those fundamentals. So even though they might be like 5, 6 months old, something like that, they're still a good resource if you're just looking to get started with Compose.
And that's all we wanted to talk about today. Thank you so much for attending the talk. You can follow both of us on our respective Twitter accounts, where you'll also find all of these links tweeted and anything you might be looking for, the slides as well. And we'd be really happy to answer any questions if someone has a question.
Yeah.